Welcome. Today's presentation covers FEM analysis of heat transfer in fins. More specifically with straight parabolic fins. Presenting today are Daly and Karan Ghuman. The goal of the project was to determine the heat transfer rate for straight parabolic fins. It was also required to determine the fin length for three materials: aluminium, copper, and stainless steel. The ambient temperature was 20 degrees Celsius and the heat transfer rate was 60 watts per meter squared Kelvin. The fin geometry was modeled in NX and then imported into ANSYS Workbench. The analysis was done using steady-state thermal analysis. Three different iterations of length were analyzed in and out of ANSYS. Each fin geometry and material was solved for in ANSYS and on paper. The ANSYS mesh analysis and results are shown. The calculations done on paper are shown in the table below. The minimum temperature for the 10-inch aluminium fin was 40 degrees Celsius. However, the result on paper fell below the ambient temperature at 16 degrees. The 3.9-inch aluminium fin had a minimum temperature of 90 degrees. On paper it was calculated to have a minimum temperature of 98 degrees, which is more accurate than the previous calculation. The 2.5-inch aluminium fin had a minimum temperature of 105 degrees. On paper it was calculated to have a minimum temperature of 112 degrees. The 2.5-inch aluminium fin had a minimum temperature of, the 10-inch copper fin had a minimum temperature of 77 degrees. On paper it was calculated to have a minimum temperature of 76 degrees. The 3.9-inch copper fin had a minimum temperature of 120 degrees. On paper it was calculated to have a minimum temperature of 122 degrees. The 2.5-inch copper fin had a minimum temperature of 128 degrees. On paper it was calculated to have a minimum temperature of 129 degrees. The copper fins had higher minimum temperatures compared to the aluminium fins. The paper calculations were also more accurate. The 10-inch stainless steel fin had a minimum temperature of 22 degrees. The 10-inch stainless steel fin had a minimum temperature of 22. The 3.9-inch stainless steel fin had a minimum temperature of 20 degrees. The 2.5-inch stainless steel fin had a minimum temperature of 23 degrees. Stainless steel fins clearly had the lowest minimum temperatures among all materials. The fin efficiencies and the thickness to length ratios are shown for all three materials. Copper and aluminium had much better efficiencies compared to stainless steel. The fin efficiencies and the thickness to length ratios are shown for all three. In conclusion, the analytical method showed values below the ambient temperature. This meant that the effective length is shorter than the length used in calculations. Further iterations should be used to determine exact length at which the ambient temperature is reached. And stainless steel showed that it had most efficiencies among all materials. Thank you, and we wish you the happiest of holiday seasons.